Okay. So, they were nice, and they gave you the rule, right? $2.50 times the weight, or how many pounds it is. So, some of you where I think you were getting a little confused is you were almost thinking too hard about it. Okay? They give you the equation. Times. Okay? If you are looking at this table, we're trying to figure out this one. What is our W in this case? W. What's our W in this case? 1. Right? 1 is in the table for the row we're trying to figure out. So instead of having this say $2.50 times W, we know in this situation our W is 1. $2.50 times 1 is $2.50.
Yeah, it is. I think she knows.
Half of you couldn't tell me what W was in the situation, so it's probably need to go over it again. Am I right?
Yeah.
Okay. So we still have the same equation. We're not changing the equation. It's still $2.50 times W. But what is our W in this case now, what we're trying to figure out?
3.
It's 3. $2.50 times 3 in case.
$7.50.
That's 6.
Okay, we're going to do it. 3 times 0 is
0.
0. 5 times 3 is
15.
2 times 3 is 6 plus 1 is
5.
How many decimals did I have in my question?
1. 1 but in 2.
Okay, you guys, the side conversations are done. Not only is it distracting to your neighbors, but I can hardly do 250 times 3 because I'm listening to someone talk about CCAP and I'm listening to somebody talk about something else and I'm listening to somebody talk about Fortnite. It's done. Okay, how many decimals are in my question? 2, right? 1, 2. So how many do I need in my answer? 2. 1, 2. Okay, I think these are the ones that we get tripped up a little bit when they give you like the opposite, right?
I don't know what it is.
Because our equation is still the same. It's still 250 times how many weights. But in this case, we don't have that W. We don't know what it is. But what do we know this equals?
$15.
$15. Divide. Otherwise, let's see.
Multiply by 0.5. No.
If you have $2.50 plus $2.50, where are you at? $5. So that's 2 times, or 2 pounds. What if you add $2.50 to that $5?
$7.50.
$7.50. Okay, so 7. Oh, we already knew that. $7.50 for 3 pounds.
You could have cheated off of that.
You could have.
Do 3 times. I mean, 75 times. Right?
Or you could do the 2 times. The $5 times 3.
Ooh. Or some of you recognize that 750 times 2 is 15. If you multiply this by 2, what do you need to multiply this by? 2. 3 times 2 is 6. So you could get 6 pounds of cherry tomatoes for $15. Okay? That one was just reversed because they didn't give us our W. We had to figure out what that was. So we had to use a little bit more brain power.
Brain power.
Okay, but our equation is still the same. So 250 times W, what is W? They give it to us this time. 10. 250 times 10, you can either write it out, or It's a nice, easy times 10, so you just move the decimal one spot. How much does it cost to get 10 pounds of cherry tomatoes?
$25.
$25. Does anybody have any questions on this part? Or how to work backwards on some of those? Or how to kind of just... When I was in school, they called it plug and chug. You have an equation, you plug in the number, and you just chug through with that, right? 250 times 10. You just chug through it, find your answer.
That's so weird.
I know, are we being appropriate? I think so, yeah. Okay. We're not going to do, since you already did some of this, we're just going to do the table for this one too. Okay, again, plug and chug through it. We know our equation is 24 times G, or the number of gallons of gas. So, we can use this every single time. 24 times, what's G in the first row? 1. 24 times 1 is?
24.
24.
1 gallon? I mean, G can say for gallon.
Plus gallons of gas. So yeah, think of it. Okay, we still have the same exact equation, but how many gallons of gas do they want us to figure out this time? 4. So instead of this saying G, it's not G anymore, it's 4. 24 times 4. In case you don't have your 24 facts memorized, 4 times 4 is
16.
16. 4 times 2 plus 1.
5.
9.
It's weird if we had 24 facts.
I know it would be.
24 divided by
That's why I never expect you to do, that's why I always give you space to work, because I never expect you to just know that.
4 equals 6.
Okay, but oh snap, this is one of those backwards ones. How do I figure out how many gallons it is to get us 168 miles?
4 times G equals 116.
24 times G, so times something, we're not sure yet.
Equals 160.
168. A perfect time to practice your long division. Okay. Dad comes in first. Dad says, okay, how many times can I fit 24 into 1 without blowing it up?
0.
None. So he shimmies over. How many times can I fit 24 into 168? None. So we're kind of back to how many times can 24 fit into 168? What do you think?
7 or 8.
I'm thinking.
Let's try 7. I heard 7 first. 4 times 7 is 28. 7 times 2 plus 2.
16.
Bingo! It fits right in the money. What did I just say? It was
7.
7. That was a good guess, my friend.
A very good guess.
Okay. Now we're back to kind of normal where they give us our G, the easy peasy. We have the same equation.
13.
It's not G anymore. It's 13. 24 times 13 again. I don't expect you to know this.
312.
We have
I'm
12,
I'm lazy.
6, 7.
You don't need a whiteboard.
Tens place. We need our 0. 1 times 4. Watch your own bother. 1 times 2 is 2. We have to add these together. Sorry, I forgot to erase this little line down here. 2. 312.
Can you also do 168 times 2 minus 24?
You could. That'd be like a couple more steps, but yes, that would get you the same answer. Okay. Any questions? When I first brought this up, somebody said they were getting stuck on this. Are you unstuck? Okay. Brilliant. Moving right along. I don't need it. You did one slice it, but you're into, this is almost like a step more difficult, so there's 2 steps. Okay, here is my biggest piece of advice. When it comes to solving number sentences or solving equations or solving expressions, whatever word they use, my biggest piece of advice is to rewrite it. Okay? Because, like in this first one, it's not just, oh, add 2 each time. Okay? There's kind of 2 steps as part of it. So let me show you. So, right here it's telling us 2 times x plus 3. So what am I doing each time to my x value to get my answer? Mason, what do you think? You are multiplying by 3, or sorry, multiplying by 2. And then add 3. That's what you're going to be doing every time. So we have our equation 2 times x. Okay, but in this case, it's not x. What do we know x is?
1.
1. So here's what I mean by rewriting. Okay? Rewrite it so you have it the way you're going to solve it. Sometimes it's multiple steps, and it's really easy to make a mistake. Because now you can just look and go, okay, 2 times 1 is?
Oh, it's 2.
2. Plus 3. Okay, 2 plus 3 is?
7. 9.
I have a piece of hair somewhere and the refrigerator. Maybe. I know, but like, my patience is gone. Officially. Okay, but now we don't have x again. What do we have this time? 2. 2 times 2 is?
4.
4.
7.
Plus 3 is 7. Okay. You see how easy it is when you just rewrite it and just do the problem through? Because this right here looks a little overwhelming to me. I don't know about you, but I see it and I'm like, there's a lot of like parentheses and there's a lot going on. Okay, what's our x in this next one they want us to solve?
3.
3. 2 times 3 is?
6.
6. I have this left over. 6 plus 3 is?
9.
9. Oh, snap.
How would you do?
We are doing a bit of algebra in this next one. Okay. We have... Now, I'm going to need to turn around one of you with me. Okay, we are 15 minutes on the clock. We don't know x, but we do know it's all going to equal 15.
You could go backwards, switch the addition sign, and the multiplication.
We can kind of undo it a little bit, right? So if I wanted to get this x alone, I need to undo what's on the other side. So what's the opposite of adding 3?
Subtracting 3.
Subtracting 3. So if I subtract 3, I have to subtract 3, right? You can almost think of that equal sign as like a dividing line. Like those are your two sides. If you plus 3 and minus 3, what happens?
You get the same 3.
You have 3 minus 3. Yeah, it becomes 0. It's like nothing. It goes away, right? But 15 minus 3 doesn't just go away. You're left with what?
You're left with 12.
You're left with 12. Okay, and we still have this stuff on the bottom.
Yeah, you
Okay? I still want that x alone, but right now I have 2 times. What's the opposite of 2 times something? Divide by 2. If I divide this by 2,
6.
I have to divide this by 2. Okay, this kind of goes away. It undoes it because it's the opposite. Okay? If you think about like if you're running a race, if you run 50 meters and then you reverse it and do the opposite, you're still left with the starting one. You didn't really go anywhere. But 12 divided by 2 doesn't totally make it go away. It makes it what?
6.
6. Oh my gosh. What is x equal to? 6.
7.
Okay, good on that one?
Yeah. Oh,
You just did algebra. You survived. You did great. Okay, I'm going to erase this again to have some room. Okay, I still have the same equation. 2 times x plus 3. Do I know my x in this next row? Yes. What is it? 8. It's not x anymore. 2 times 8 is 16. I still have the plus 3. That is 19. Oh, it's still a little more algebra. Okay, if you didn't notice, algebra I think is like my favorite part of math ever.
You'd be good in math, master.
Like I like fractions, but I love algebra.
You'd be a great student for yourself.
For myself. My father's probably smarter than that. Hey, do I know x in this last row? No, do I know what it equals? Yes. I know it's going to equal 3. Okay, I kind of have my 2 sides. I'm going to start with this stuff over here on its own. Instead of adding 3, what's the opposite of adding 3?
Subtracting.
Subtracting 3. I have to do it to both sides. This goes away. 3 minus 3 is 0, but I still have this left over. I want that x by itself, so how can I undo multiplying by 2? Divide by 2. If I divide this by 2 and divide this by 2, this goes away. What's 0 divided by 2? 0, right? If you have 0 cookies and you divide those cookies into 2 groups, how many cookies are in each group?
0.
Still 0. Oh snap. Oh my gosh.
Are you turning this color does that?
I know.
Oh my god.
Oh my gosh.
Are you Mrs. Kors in that?
I wish. Someday I want to be just like Mrs. Kors and the flowers and Mrs. Doodle.
Yay. This is the keyboard.
She'll be back at the end of the day. Okay, if we graph these points, our x, remember our x is always down at the bottom, and our y is always over here. Our x is 1.
Wouldn't you start at 0 though?
No, because the x is going over and then you have to go up like that.
Yep, so this one's at 1. We will have a 0 point eventually. But yep, because we have to follow exactly what this coordinate is. So the next one is over 2 and up 7. Over 3, up 9. Over 6, up
Way up to 15.
15. I know, I almost can't reach. Oh, 8 and 9. Okay. 8 and. Okay, 19 was what as far as I could go. And then when x is 0, so it's 0 over here, it was up to
Wow.
3.
Mine is so pretty.
You know, hopefully I won't mess this up.
Oh, it's just that.
Oh, it's not the straightest one, but it's not too bad. Okay, how are we doing? Thumbs up, you like feel great, you're loving life, you're rocking this. Aside is if you're like almost there, you're getting there.
Life is down here. I'm here.
Okay, like math, like specifically what we just said. Awesome. Okay, I have one more thing for us to get through. We'll see. Both of these worksheets you will be taking home today, okay? We just did the one.
No way. Math get harder or easier?
Does life get harder or easier?
Harder.
Yeah. I mean, if you are working hard, it might be hard to go.
Because he makes my
Yeah, I mean, the skills themselves get harder, but you are also smarter. Okay. If you become a scientist or any type of science, they use a lot of math. Okay? One way that scientists have used math is way back in 1897.
That's up there.
Yep, a long time ago. There was a physicist called A.E. Dolbear.
That's a really cool last name.
Okay? And he did this big study, and he concluded that he could figure out the number of chirps a cricket is going to make depending on the temperature. So he was saying if it's a certain temperature, he knows they are going to chirp so many times. Okay? And he decided that the outside temperature, so the degrees in Fahrenheit, would equal the number of chirps per minute minus 40 divided by 4 and then add 50. And if he could count the number of chirps that those crickets made in a minute and use that equation, he could tell you the temperature outside without a thermometer.
I want to see this person.
Okay? Pretty smart guy for that long ago. Okay? So, but we know that this isn't actually how like math number sentences or math expressions are written, right? They don't like all those letters. They just use one letter to represent something. So, what do you think outside temperature, what letter could we use? T, right? T for temperature. How about, we're not going to write number of cricket chirps per minute. Remember, only one letter.
And
So maybe, let's maybe do C for cricket chirp. Okay, we know that we have to take and subtract 40. And divide that by 4. And then add 50. Okay?
It's like a fraction.
So our equation is the same thing that physicist Dolbear came up with. We just shortened it up. We made it that many less, kind of takes us that much less longer to write it.
Why did you make this, or is this based on the truth story?
Yeah, it's good actually for yourself.
That's why I said I want to be this person.
Yeah.
I want to be a cowboy.
So it says according to this formula, what is the estimated outside temperature if you count the crickets chirping 80 chirps in a minute? Okay, so we don't know T, right? That's what we're trying to figure out. We want to know what the temperature would be. But do we know what C is?
Yeah,
It's 80, right? So we know there was 80 cricket chirps in that minute. Oh, I'm sorry. The rest of the equation stays the same, right? We're going to subtract 40. We're going to divide by 4.
I think it's 50.
And we're going to add 50.
It's 54.
Okay? Again, this looks a little overwhelming. Take a deep breath. We're going to do it step by step.
84.
Okay? What is 80 minus 40?
40.
40. Okay? Remember I said rewrite it, it helps?
Yeah.
Okay, 40 divided by 4 is?
10. It's then 10 plus 50.
10 plus 50
Which is
10 plus 50 is?
60.
Don't forget the F. Because they might not, it might be,
So
it might be Celsius.
Yep, T equals 60. So if you heard a cricket chirp 80 times in 1 minute, the temperature outside is going to be about 60 degrees.
Yeah,
My brain is overfilled.
Could you imagine being a physicist and figuring this out?
What if it trips?
Probably not.
How many words a cricket talks a day?
I'll put my check. It depends. I mean, but what if you only chirp one time? Probably.
Okay. That is one cricket formula. However, some other scientists have kind of worked off of that original formula and figured out more accurate depending on what kind of cricket. So someone else came around, I'm not sure who, and they said, okay, I think it's even more accurate with specifically field crickets.
What is field
Like a kitten like that lives near like field.
No, to its name.
And they said that yeah, this formula works, but specifically for field crickets, this one's way more accurate. Okay? What's a formula or an expression or a number sentence we could use to write that? T, so the outside temperature is going to equal what? We're not going to write number of chirps in 15 seconds. We're going to write what? C. We'll use a C. And?
Shouldn't we do FC? No.
Nope, only one letter. Yup, good question.
And that's it.
What the TC for the game? I was going to write 73.
What do you notice kind of a big difference between this formula and the last one is?
It doesn't do a bunch of other numbers. It's not as many numbers, and you only have to do one step.
True. How about when you're counting the number of chirps?
It has to have add by 37, which is a very weird number.
It's 15 seconds in this one, where how long did you count chirps in the first formula?
40 minutes.
For a minute.
Oh, times 4.
For a whole minute. So this one you only have to count chirps for 15 seconds. So now they want to know, according to this formula, what is the estimated outside temperature if you counted 35 chirps? Okay, so let's look at our equation. Do we know what T is?
We know it.
No, that's what we want to figure out, right? We don't know the temperature. We want to know it. Do we know what C is?
Chirps. 35.
35 chirps
Plus 37.
plus 37.
It's nice and warm out there.
35 plus 37, if you need to write it this way.
72.
Oh, I should shake It's nice there.
It is about 72 degrees out there.
I really wish that would happen here.
Yeah, at least once a week.
Yeah, it's great. It is seriously, I don't.
Okay, now they want us to compare the two formulas. So they're saying, okay, you want to know which one is more accurate, or kind of what's the comparison. If we go to 30 chirps in 15 seconds, we need to figure out with both of our equations. So we don't know the t for the first one. Okay, the first formula was this one, remember? Do we know what c is? It's 30 chirps in 15 seconds.
So maybe if you times that.
Okay, what is the issue? Oh. Okay, so they asked you to stop, so please stop.
There are 15 seconds and 60 seconds.
Okay? Because remember, there's 30 chirps in 15 seconds, but how long did you have to count chirps in the first one?
For a minute.
Per minute.
Per minute. So 15 seconds, 30 seconds, 45 seconds, 60 seconds. So what do we need to multiply that 30 chirps by? 4, right? Because there's kind of 4 of those pieces of 15 seconds. So we had 30 chirps times 4 will give you 120. So that's the number we have to put in our equation. If you would have just put 30, you would have gotten the wrong answer.
Holy, it's hot out.
Okay. So there was 120 chirps. What else do I need to do for this equation? Mr. Anderson? Remember, we're using the first equation.
Subtracting 40.
Minus 40.
Divided by 4.
Divided by 4. And we had to add 50 at the end, right?
Oh, yeah.
No,
It's
it's
Yeah, do the rest of the worksheet. Okay, so again, don't panic. It looks overwhelming, but it's not that bad. Take it in pieces. What's 120 minus 40?
30.
It is 80. If you need to do that on the side of your paper, that's okay. Okay, the rest of this stays the same. Oh, no, we just did the minus 40. I'm sorry. Okay, what is 80 divided by 4? 20. 20 plus 50 is 70.
I forgot to divide right away.
Right. Stop. Okay, so that's how warm it would be outside estimated for the first equation. Let's see how that compares to the second equation. So this was the second one we used. Do we know the temperature?
We do not.
Nope, not yet. That's what we're trying to figure out. Do we know C? What is C? 30, right? 30 chirps in 15 seconds. Does that time frame match with what we need?
Yep.
Yep, because this was number of chirps in 15 seconds. We have 30. What's the rest of the equation?
Add
Add
37.
Add 37. 30 plus 37.
So those are pretty close.
They are pretty close.
You gotta round it if you don't want to round
Probably 3 away from each other.
Yeah. I'd say they're both pretty accurate.
it. Maybe you could go for, maybe you could just try to find the middle of them.
Okay. Any questions? Get stuck anywhere? No, are you feeling okay? Okay, since we are having some issues with the time, people are purposefully not doing their work for the timer. So instead today you need to do 20 questions. Or if you get to 100 before you answer 20 questions, you don't have to do any more.
40 questions.
Yeah, you just have to tap the timer first, and what if people
Okay, so if you tap the timer, it will show you how many questions.
Which means on the
people are
app.
just guessing to get past their question? Yeah.
Well, okay, so remember I said if you're just like rushing through these, you're probably not going to get a very good smart score, right?
No.
To me as a teacher, if I look and I go, oh man, they did 20 questions and they only got a smart score of 15, they probably need to come back with me and practice some more, and I'll tell them they need to work on more questions. So if you just rush through and answer whatever, you're probably going to get more to do, because you're going to be basically showing me that you don't know how to do it, when really you do. You're just kind of being lazy.
I'm pretty sure it's impossible to get to 100 after 20 questions.
Well, and you're doing 20 questions.
I'm pretty sure the minimum is 5.